Okay, good morning. Welcome back. Happy Thursday. I have handed back the quests. Everybody has their quest? Yes? Yes? Okay. So just for your information, I've got the highest grade in the class here was 97, and the median grade was 89.25. Median means if we lined everybody up from highest grade to lowest grade, the person right smack dab in the middle was at 89.25. Said another way, half of you did higher than 89.25 and half of you did lower than 89.25. And I will say that, I mean, this is an absurdly high median. So on the one hand, awesome. But I also want to be realistic and straight with you guys and say that this quest is the easiest assessment that we're going to have in class the whole semester. The material is I'm just trying to be real. The material definitely gets harder, and I think a lot of what we've done so far on this quest, at least, was a review, right, or at least partially a review from previous math classes. So, not trying to put the scare in anybody, but just trying to say, in order to maintain whatever level you got on this quest, probably is going to require more work. The same amount of work in the future is probably going to result in lower quests and test grades as the material becomes tougher and maybe less familiar to us. So hopefully that is motivational. But anyway, that's for your information. You're not in a competition with anybody else, but just wanted to give you a sense of the level of difficulty of this particular quest. What's that? Last time will help too. Yeah, missing a week does not do good things for quest grades. So also wanted to say that there are, just a reminder that we've got all these YouTube videos as a resource. Somebody sent me a nice email the other day just about how helpful those were. So I mentioned it on the very second class, but I'm mentioning it again today. I make videos of all of my classes, including right now, and I also have videos of all of the problems in the practice problems packet. And those videos obviously are available 24/7 anytime you're online, okay? All right. So we're going to jump in. Today we are doing all of lesson 7 and we'll start lesson 8. Lesson 7 you can see here is additional properties of lines and it starts on page 55. So let's jump right there. Okay, in this lesson we explore properties of horizontal, vertical, parallel, and perpendicular lines. 4 kinds of things that we're going to talk about. There's not a lot you need to know about each of these 4 different kinds of lines. We'll talk about exactly what it is that I need you to understand about them. An important note, we're skipping sections 2.1, 2.2, and 2.3 in your textbook because they cover functions, which is a concept that is not part of our curriculum. But that means that starting with section 2.4, which is where we are today, your book might use the word function because it thinks you have done it in sections 2.1, 2, and 3. And so from this point forward, if you see the word function in your textbook or in your homework, you're going to mentally replace that word with the word equation, okay? So function becomes equation. So, and if you see these symbols F parentheses X or G parentheses X or H parentheses X, you're going to mentally replace each of those symbols with a single Y. And so for example, here we go. If you read, consider the function F parentheses X equals 3X minus 2. If you see that in your textbook, you are going to change that. Function becomes what word? Equation, and then this F parentheses X becomes Y, and so you translate all that stuff in quotation marks to consider the equation Y equals 3X minus 2, which is probably a whole lot more familiar and friendly looking to us, okay? Here with number 1, consider these points, 7, 2, negative 4, 2, and 0, 2. Real quick, go ahead and plot those 3 points on that top grid. And there is a single line that connects those 3 points. And what word could we use to describe that particular line? It is horizontal. Everyone agree? Okay. So the word is horizontal. This is like an embarrassing admission, but I was way too old when I realized that the word horizon was inside of horizontal. I never made that connection. Never made it. Okay, let's write an equation for the line that passes through these 3 points. What is consistent? What is exactly the same about those 3 points? The y coordinate is exactly the same. And how much is it? It's 2. And so if I wanted to define an equation that got across the concept that y was equal to 2, would write y equals 2. That's the equation of that line. I mentioned today 2 of the special lines we're talking about, a horizontal and vertical. That's the equation of a horizontal line, is y equals some number. In this case, it's 2's, but it could be anything, right? Let's think about the slope here. We remember that the slope we used m, and the slope is the change in y over change in x. That's our definition. And so let's just use these 2 points right here. How much does the y change? We do 2 minus 2 is 0 on the top. Actually hardly matters what's on the bottom, but let's do the calculation. 7 minus negative 4 is 11. And what is 0 over 11? 0. So the slope of that horizontal line is 0, and in fact the slope of every horizontal line is 0. There's never any rise, so you don't go up at all. You got lots of running, but no rising. We'll summarize all this at the bottom of the page. For now, let's move on to these 3 points. Same game as before. Plot those 3 points. And what word would you use to describe the line connecting those 3? That's vertical. This is one of my pet peeves, but people misspell the word vertical all the time and it drives me nuts. A-L, A-L, L-E, all the time. All the time. Don't laugh, people in this room wrote L-E, I guarantee it. There's enough people in this room to think that some people, and the same thing with the word like nickel. Like I get L-E at the end of nickel too. All right, vertical, write an equation. Okay, what's consistent about these 3 points is that the x is the same, and in this case, it's 4. And what do you know? Nope, it's just x equals 4. It's really tempting to think that like the equation of every line has a y and an x in it. That's true for most lines. Y equals 3x minus 7, y equals 2x plus 5. Usually there's an x and a y, but vertical and horizontal are the exceptions. They are the special cases, which is why we're kind of tackling them separately here. Every vertical line is of the form x equals a number, and there is no y in that equation. And if the only thing you know about lines is our old friend y equals mx plus b, that's not going to do it. You cannot capture a vertical line if you write y equals mx plus b. You are dead in the water as soon as you write y equals mx plus b. It just cannot be done. It seems like every line should have that form, right? That's like our standard generic equation of a line. And as soon as you know the m and the slope and the y-intercept, you just plug them in, right? Well, let's calculate the slope here. M equals, okay, again, change in y over change in x. I will randomly pick those first 2 points again. Change in y, 5 minus 2 over 4 minus 4. Upstairs is a 3, downstairs is a 0. What can you say about the fraction 3 divided by 0? Is what? It is not 0, it is not 3. It is undefined. We cannot divide by 0, right? And so this is why the mx plus b cannot capture a vertical line, because there's no slope you can plug in. The slope is undefined. Slope does not exist. Okay, so big conclusions. The equation for a horizontal line has the form y equals some number. Every horizontal line is y equals some number. The slope of every horizontal line is 0. And now the 2 facts for horizontal. The equation for a sorry, that was horizontal. Here's the vertical stuff. The equation for a vertical line has the form x equals some number, and the slope of every vertical line is undefined. 4 facts, that is the only stuff I need you to know about horizontal and vertical lines. I encourage you to really treat them separately, not even think about y equals mx plus b for any vertical or horizontal line. Just use the 4 facts. On the next page, here's an example. We're going to skip number 4. You can read it later if you want. We're just going to do number 5. So 5 is a typical test or quest question. Find the equation of the line that has m equals 0 and passes through 3, 2. So I'm just going to write down we're going to think it out loud, and then we're going to write down just a couple of things. As soon as I say m equals 0, I'm already in the mindset, oh, this is one of my special lines. What kind of a special line has m equals 0? Is it vertical or is it horizontal? It's horizontal. If you're not sure, just go back. You got everything on the bottom 2 lines of that page. You can refer to that today in the activities and when you're doing your homework. So the first translation is, Ian is playing games. It really means to say, find the equation of a horizontal line. That's the translation that we do first. And then the next step is say, okay, every horizontal line has a special form for the equation. It is always either x equals a number or y equals a number. Go back and look if you're not sure. What is the equation for every horizontal? It is y equals, I'm just going to put a little number sign here. It's y equals some number. And then the last piece of this one is to just find the number. At the only point that I have, what is the number? It is 2. It is not 3. Make sure you grab the y in this case. Y equals 2 is our answer to the question. Okay? These questions are supposed to be straightforward and they look pretty easy. When you see somebody who knows what they're doing, do it. And I just need you to get to that place. Become the person who knows what they're doing. It's supposed to be easy. But if you don't know what you're doing, it's really easy to go wrong. Okay. Okay, so that's everything about horizontal and vertical. Here's some stuff about parallel lines. These 3 lines graphed over here appear to be parallel. Looking at their equations, we see they all have the same slope. We see that? Here's the equation y equals 2x plus 4. What's the slope there? It's 2, just the 2, right? Not 2x. Just the 2. Y equals 2x minus 1. Slope is 2. And y equals 2x minus 8. Slope is 2. And that's pretty much the defining feature of parallel lines, is that they have the same slope. That's all I need you to know about parallel lines. They have the same slope. It actually kind of makes sense that parallel lines would have the same slope, because remember, slope is just a measure of steepness, right? It's like how much do you run and how much do you rise? And if you are a parallel line, then it's going to be like this same, like exactly the same triangle, right? If the lines truly are parallel, it's going to be exactly the same relationship between the rise and the run. Okay, so same slope. All right, and then down here, a little bit trickier is perpendicular. So here are 2 perpendicular lines. It's kind of hard for me to see the axes up on my screen. Is it easier on yours? Yeah. So, so what I want to know is the slope of these 2 lines. Now, to calculate slope, you need to find 2 points that are on one of the lines, like 2 nice points. So, can I get these 3? Everybody, look up here. These 3 tables right here are going to find the uphill slope line, the uphill one, and then the other 3 tables are going to find the slope of the downhill line. So again, what you got to do, check with your neighbors. You got to find 2 points that are on your line that are nice, that have nice coordinates that you can just read off. Check in with your neighbors. Yeah, that one is yours. Yeah, that's the downhill one. You have the uphill one. Yeah, you guys are doing uphill. Uphill. 5/1, that sounds okay. You guys see that? So talk to each other about how do you find, you got some points that you put dots on right here. How did you pick those? Okay, let's get some numbers here. Uphill line, what's the slope of the uphill one? So you have 0.4 as one of the nice points. Yeah, and then when you did the slope calculation, what did we get? 5/1. Okay, so that's fine there. So slope is just 5, but I'll leave it as 5/1. So this concept of grabbing nice points, that's important. We're going to use that a bunch this semester. So make sure you're clear. If I give you a line, I'm probably thinking about 1 or more points on there I want you to just grab. And then my downhill people, what's the slope? Okay, so then the slope of this other guy is -1/5. And there is a relationship between the 2 slopes. Again, these are not random lines. These are lines that are perpendicular to each other, meaning they form right angles, right, 90-degree angles. Okay, so there's 2 differences to get from the one slope, the blue, to the purple slope. What's one thing I have to do to the blue? I got to flip it over. What's the fancy math word for that? Find the reciprocal, right? That's a reciprocal. But there's another change. What's the other change? Is the negative. And would you guys buy, does it make sense that if that if one line is uphill, that the perpendicular line has to be downhill, right? It makes no difference. Like as long as I got one uphill line, the perpendicular has to be downhill. And you know that every uphill line has what kind of slope? Positive, and every downhill line has negative. So totally believable that you got to have opposite signs, right? So two things you need to do to find perpendicular slope is you do the reciprocal and you change the sign. Okay, so you are going to use these facts in the activity. The activity is here. Some of these questions are going to be fairly straightforward, but some of them we're really going to kind of make you work. So take your time as you go through these and ask your neighbors for help, and I will walk around.